Good morning, everybody. It's 9:10. We will start. Happy Friday. Welcome to class. We are going to, it's a milestone today. It's a milestone in the sense that we have completed a good set of topics, and we are going to start a good stretch of new topics starting from next week. And today we will talk about semester project. And one way or another, many of you have been kind of asking about this in the first week of class and a little bit after that and so on. And so this is a perfect moment for us to have this discussion, and it is going to be dedicated to talk about it. I have, unlike other times where I have the slides posted ahead of time, not done so because it is much better to do it this way, but there are a couple of documents that are posted already, and we will get to them at the end. So we'll be using this slide to talk about semester projects today. So the class has come to a point where I would say, here I declare you all ready for projects is what it means. And so as you will see, you will have topics that are coming that will be needed, but at least we've got some of these basic gears out of the way, and we are ready to have this discussion now. I did not forget, we do start our day with a warm-up question. And it's Friday, and I want it to be easy thing for you to think about and answer, but it has got a very slight connection to what we would do at the very end in terms of what projects are coming. And the topic, just roughly, the warm-up questions topic is music, around music. And my question is for the day is this: who is your all-time favorite musician? A person. We've talked about this in terms of genres and things like that before, but this time I want the artist, the musician. And Fred is going to be the person who will have the honor of writing today's warm-up question. Fred, I hope you're hearing me. I know you're there. So go ahead and type the warm-up question for the day. Who is your all-time favorite musician? And you will get a sense for why this became related in a very surprising way to what we'll be talking about today. All right. Get everybody comfortable, sip your coffees, and so we have started, and Fred is going to write the warm-up question if he hasn't already, and I'm going to do my usual thing on chat analytics and let you know who your favorite artist is after the class is over. And we will also have the slides posted, but we've got material that will be relevant for the discussion that's already posted. Let's get started, okay? Here is a place where I want us to pause for a second and see what topics we have covered, what is left, and just celebrate the fact that we have become on time and get a good things out of the way. There are colors here. I know your favorite colors, so I did not have any other choice than using crimson and gray, and so they're there. But I know the vast majority of you, last time when I asked you, said blue is one of the favorite colors, so blue. Okay, so we've got 3 blocks here. The thing that you see in red block is what we have covered so far. And the thing that you see in the other color, gray, is what is left to do. So we're in week 6. We're completing week 6 now. And the previous slide had shown us this is the first lecture we're having, or the first meeting we're having in the month of October. So we finished in entire September and a couple of weeks in August. And so that will make it 6 weeks. And so in those 6 weeks, we did a week on what is data science. We had an introduction to R, and we spent some time talking about exploratory data analysis and the data science process. And we did spend the last few weeks talking about a relatively big topic on data wrangling, and looked at what data manipulation techniques, using tidy data, what it means to have data in a structured fashion, tidy, and relational data. We had a lecture spent on it, talking about joins. And the last 3 lectures, including the one that was a guest lecture, was on data visualizations. And data visualization originally in the syllabus was pushed down, was like topic 11 or something, and we pulled it up, and I think that was a very good decision to do. So we have covered these 5 topics. The syllabus, I set up so that there will be 5 assignments, and there may be an opportunity for us to have 6. We'll wait, but we have 4 of them taken care of. 3 of them actually submitted, and the 4th one on joins and data visualization, as you know, was out last Wednesday, and it will be due next Wednesday next week. And so that was on joins, one of the topics in data wrangling that had to do with relational data and data visualization. So if you think about what we've done on the left, that's quite a lot for 6 weeks, really. And I think you have been good at keeping up with these things. There were different paces. There were times when I was careful and going a bit slowly. And then there was a time when we had to kind of speed up and finish many things. And so I don't want you to lose anything that was said and you didn't have time to do it. So make sure that you are now this, and by the time you finish assignment 4, I think that will be the case. Assignment 4 has got one problem that was first thought to be just a fun problem to know where you grew up, but it turned out to be a component in one of the visualization topics you have there. And so there is a room there for a little bit of research on your own, but if I need to provide any guidance or anything like that, I come up with, I will. Make sure that you if you have questions to ask about it, ask me. The source for it, the text file you have is names of cities and states, or names of states and cities and countries, and your task would begin by having to find the latitude and longitude for them, and then you would visualize them. You have a lot of freedom there, how you want to do it and things like that. And the more you spend on it, the more credit you would get. But I'm not going to have too much of an expectation in terms of really nice looking ones. But at least the basics would be, I think, a good thing for everybody to understand. The other problem, the join problem, is a fun problem and a little bit of creativity. And then the one on word cloud should be something that you would benefit personally having to do it. Okay, this is what we have done. What you see on the right is the topics that are left. And I think it is good for us to have this one so that this discussion around the projects would make sense. And it is unavoidable that many of the projects will have things that would be on upcoming topics. I've told you this in the first week of classes also. If I was to wait until all the topics are covered and then say, here is a project, we'll need another semester. We don't want to do that. And so I think it is good to select a project and know what kind of topics are there. When they come, you would understand and use them. And for those of you who select a certain thing, you can read ahead and get started before we even get to the topic. So one way to characterize the topics that are left is to call them machine learning topics. That will be a good, fair characterization. And so we will begin next week, Monday, on having an overview of machine learning lecture, where we would just see how problems are classified, what it means, and that type of an overview. It's not probably easy, or I will try to cover this in one lecture, but if we need to borrow a little bit of time from another lecture, that will be okay also. But let's say there will be one lecture, and so these topics are not uniform in the sense of how long they would take. So the overview of machine learning, we could say a lecture plus a portion of another one at most. Otherwise, it will be dedicated to just one lecture. Then the other topics that are coming are going to have at least a week each. Linear regression is an important topic. This is one class of problems, and we will learn things there. And this is the place where you see predictive modeling or predictive analytics, that people would call it. That type of topic is what is coming in 7 and 8. And you will see a level of modeling, a level of rigor that's different from the kind of things that we have been doing so far. They were heavy on libraries, they were heavy on programming language, they were heavy on things that have to do directly with data. Here is a place where, if you remember the data science process discussion we have had, where you would model. Most people think that is where most of the time is spent. It is wrong. You will have to understand how these models work. You will have to have more like, not just as a black box, but at least understand what is going on inside, so that your algorithms would be chosen right, and they would have to be justified, they would have to be interpreted. For that reason, you would need to know enough inside them. So there won't be a lot of mathematical things that I want to focus on. I will whenever it is needed, but there will be a different level of rigor compared to the topics we have covered so far. So linear regression is one big topic that we will have at least 3 lectures or 4 lectures, and those are the keywords that we will be covering. Then comes classification. This is a much bigger class. Much of machine learning is classification. Much of the things that you would see, problems that you would encounter one way or another, would become classifications. And we will learn what that means, especially after we have an overview of machine learning class. Once we know what that class of problems is, or class of problems for classification, we will have a whole bunch of algorithms. And so these are some of the most common ones that I want to touch on. And that's what you see in the list here. And so it would probably be longer discussion that we would spend compared to regression, so a couple weeks. The resampling methods is shorter, but there are two very important topics that I want to cover there. Cross-validation, which is needed whenever we have anything to validate, and it is a method that I want everybody to have a good understanding on. It's surprising that sometimes it's not used the right way, and so cross-validation, and one method called bootstrap for resampling. So when we get there, we will have. I hope we'll have two, but otherwise we will try to cover this one in one lecture. And so it will be shorter than what we will do in topic 7 and topic 8. 7, 8, and 9, these are topics that could be called supervised learning. Unsupervised learning would come after that, and that is more of things where you do not have a function to find, is basically what it would mean. When we get there, you will know. There's two major topics I want to cover there: principal components analysis and clustering. Clustering now is a word, just I used it one, but it will be unpacked and we'll learn very different methods for doing clustering. Time series data mining is a topic I want to cover, and I think we will probably have maybe a lecture and a half on it, but I want that one to be useful, especially for those of you who will be dealing with time series type of data. Electrical engineering students are a good candidate for that, and I know there is a good number of you who are from others. This could have been moved up and down, and it doesn't have any dependence in a way on what we'll be doing in 7 to 10, 6 to 10. And one of the things I debated was to bring it up, but I also want to get to the machine learning topics faster. So let it stay where it is. And if you choose a topic that would deal with it for your project, then you will learn, and I can point you to things that you would need. Deep learning, I know, is a popular topic, and we will spend a few lectures, at least a couple or two or three, and you will learn some basic things. And that will be a compact discussion. And if you choose to have a project that would need it, then you cannot wait until that time for you to do the project. So you'll have to the reason that you would pick a project that would require deep learning, my assumption is you have some background and you will be okay. And by the time we get there, it will be reinforced. For those of you, it will be an introduction. And then we'll wrap up with a discussion on ethics. And that is going to be at most a lecture, other than wrapping up. Okay, that's where we are. This is what we have covered, and this is what is coming up. And I am going to start with talking about projects, but I want to remind you. How things are set up. I have two audiences. Some of you are taking this one as 475, and a good portion of you, 1/3 and 2/3, I should say, are taking it as 575. So far, you have not seen much of a difference. There will be the upcoming assignment in assignment 5, and if we have a 6th one, there will be a place where I would say, these are the questions 475 students would answer, and here are 2 additional questions 575 students would answer. That is one way in which you would see the difference. The other way in which you would see the difference is 575 students have something on top of the 4 components in terms of coursework that they would do, and that's written in blue. The other 4 pieces of work, coursework, are the same. The percentage distributions are different, and the project that you would choose could be different, and my expectations are different, but I will get to that point when we talk about team matching and things like that. When there is a need, if there is a desire, I would allow a 475 student to match up with a 5 or team up with a 575 student to do a project in rare cases. But otherwise, I would have a slightly different expectation on what projects are and how much time you would spend on them. This is where the difference is coming. Okay, first let's talk about the common things. Assignments. Very, very fortunately, we have 4 out of 5 or potentially 6 done. And so it was heavy on assignments now, and it will be lighter on assignments and more focus on projects coming in the future. That is coursework part 1. The other semester project, it is 40% for each one of these versions of the class, and this is the biggest proportion, and this is for a reason. I have taught this 4 or 5 times so far. One of the feedbacks I get, and I strongly believe, is the best way to make the most out of this course is to do a very good job on project, and you will learn a lot. You would get a chance to put together things that we have been learning and deliver something for yourself, something that will be meaningful, and it could lead into a significant thing. For those of you who are in 575, it could be a major breakthrough in your research, for example. And so it takes 40%. I have one exam. And that exam is a midterm, and it's going to be late. And I have given a rough indication on the syllabus when you first see it. I don't want you to bother too much about it now, the time, but we will get to a place where we'll have a midterm that would cover the topics that are covered up to the point where the exam is happening. This is a chance, it's assessment, first of all. Okay, you're familiar with the notion of exam. There is nothing new there. But it is also, I would also like to give you a chance where you look back at all the topics and review them and have them, internalize them, and be able to kind of have them. So because many things get covered and maybe sometimes you don't have that chance to read through. So there is no finals. Instead, we will have the final report for your project on a day that would have been an exam for a final. Okay, so there is one midterm exam, and it is going to be a late midterm, and the date that is indicated in the syllabus will be a good rough indicator. Class participation is important, and you're doing fine, but it accounts for 5%. That does not mean attendance. If there was a reason for you to not attend a class for any reason, you're not going to be penalized for it or anything like that. But class participation, active, like what you have been doing, and whenever I have asked you something to participate in, is what counts. And I would just want to remind you that it counts for 5%. For 575 students, survey paper is not something we'll talk about now, but it is described a little bit in the syllabus. When the time comes, I'll talk a little bit, spend 10-15 minutes in the lecture or talk about it, but try for now, just think of it as something that you would try, if you can, associate with what you do with a project. There is a good reason for that, and there is also a reason against it. You might also want to dive deeper into a particular topic that we are covering that we don't have time in class for, that you would want to do a survey paper on. Because that is 575 specific, let me postpone that to another discussion and focus on semester project now. All right. Pause for a second. First, let me give you an overview. This is a significant part of the coursework, 40%, as we have said. It would give you a chance to integrate and apply everything that you've learned in the course. And if there is a specific idea, specific aspect you want to get deeper into, then you get a chance. That is what it would give you. It's going to be teamwork. You might have noticed all the assignments so far were individual. So you were asked to do individually, you were submitting. For some of you, it was a significant amount of work in a way, for all of you, but some of you do very good work in terms of being thorough. And so you were asked always to work alone. The 5th assignment will also probably be like that. If I add a 6th one, I might consider having people to team up. The project is completely different. Here, I want people to work in teams. And the ideal size for a team would be 2. But sometimes, if it's large enough, I would allow 3 people to be in a project. It's a very rare case, extremely rare case, but if there is any reason that somebody would have to work alone, I would allow that. But I will have to have a good reason for that to happen. So the norm is it's a team effort, and there will be things that you would work together, and then you would submit one thing together. When I come to a place where I talk about what needs to be submitted, I will explain. So projects are team-based. Ideal size is 2, 3 is allowed. You will have a degree of freedom to do what project you want to do. One of the things I will do today is introduce the ideas I have, and I have already posted a document that talks about project ideas. It's going to take you some time to just familiarize yourself and see what those ideas are, browse them, and in fact select. That's not an easy problem, but you'll have enough time to do that. But that's only one pool. The other pool is your own interest. And I have been encouraging you to think about projects all along, and I know some of you have already some ideas, but you'll get a chance to actually say what that project is and tell me what it is. So you have degree of freedom to choose a topic, and you have also some ideas to choose from, is what this one is saying. What is a project? And this is a place where I want you to pay close attention to now. If you have seen how these assignments were, they would focus on a certain topic, and that is what it is focused on. And so you've got a sense for the extent of it. Think of a project to be a much different scope, scale. So it has to be significant. It will have to encompass very many of the things that we say in the data science process, and not all of them are, of course, created equal, but it will have to have that type of collections. And for those of you who would be proposing your own ideas, you should understand that. If you give me something that would have been what is going to come in assignment 5, for example, now on a linear regression problem, or what's going to come in another assignment on a classification problem, that would not probably qualify as a project. It has to be deeper. And what I'm trying to do here, and the document that I have posted, in addition to the project ideas document, there is a separate document that is about project description. That's not slides, and I will point to that document later on. Will tell you, we'll talk about this sort of thing. So it's not just these slides that you have a place to read for. So I'm going to try to categorize project types, and there are 5 of them that you see here, or 6. So the first type of project would be to analyze an interesting data set and build a predictive model for it. The data set is interesting for all kinds of reasons. So it doesn't have to be a trivial one. A small one is what I am trying to say here. Size also is not necessarily the most important thing here, but there is an interesting data set and you build a predictive model for it. Predictive model means you're solving a supervised learning problem. You will learn about that on Monday, but you have something that would say for when something new comes, you have to predict for it. That is one type of project. Another type of project is you still have an interesting data set, you analyze it, but you're not going to necessarily have, not all problems are about prediction, but you might have some insight to draw to discover some knowledge. This is also called unsupervised learning. This is also sometimes called data mining, that you are trying to find knowledge out of it. And there are a whole bunch of type of very interesting scenarios where something like this is the right approach. So you could have a project where your goal is to build a predictive model. You could have a project where your goal is to look at an interesting data set and draw insight and discover knowledge out of it. The third type of project is about a method. So to build a predictive model or to discover knowledge doesn't necessarily mean you will have to use a new model, a new method for doing classification, a new method for doing it. You could use an existing one, and your contribution has been the creation of the model, has been the discovery of the knowledge, the drawing of the insight. That was your contribution. That was what the project was about. But most of us, like myself and many of the people in my department, would be doing methods that would be newer, that would be improving things, that would be scaling better, they would have given higher accuracy, or they have put another thing from another place. So you have a novel method to contribute. This will be, for example, what I would expect a 575 project to be compared to a 475 project. You have an opportunity now to come up with something algorithmic. So develop a novel. The keyword there is novel. That's project type 3. Type 4 is you conduct a study comparing models and algorithms for a chosen problem. There are very many times, and this is quite common, you will notice if you get deeper into this, or you get a follow-up work, or you continue your research on this one. There are alternative ways of doing something, and there are different models that you could use. There are different algorithms that you could use, and it's not always clear which algorithm, which model to use for which problem. And sometimes a careful experimental study is insightful, and that type of project was welcome. So you're not making a new model, or a new novel method. You're not developing that, but what you're doing instead is a comparative study, experimental study of different models or algorithms for a problem that's already decided what that problem is. That was 4. Number 5, or type 5, will be to build a data product at a specific purpose. Data product is a word I have used in the first week of classes, if you remember. A very good example of a data product would be a recommender. I have seen cool examples in past project years where people have designed a recommender for music selection, a recommender for having to die, I think it was for sewing. And I will show you a couple of videos when we get to some point of some of the projects that I have seen in the past that were nice. But you build the recommender system, that's more of product. There is something that you have produced that people could use. And so that will be a nice type of project. Or you could have a visualization of a complex data set. This past week was an excellent example for seeing what that would mean. So you will have to create a visualization for a fairly complex data set, and that will be a fair type of project. Okay, you might have noticed when I talk about this one, so you could say, oh, I have an idea, but it will have, A and B, or the first type and the third type together and so on. Yeah, that's wonderful. In fact, That's the most desirable thing for a project, to have a combination of some of these items. Probably it will be an exaggeration to say all of them, but some combination of these would be a desirable thing to see in a project. Okay, we have talked about the types. This was a question I got last time. What are the milestones? I have got very simple ones. It's out today. You have a document to look through. You have been introduced what the setup is. On October 12th, I think it is a Monday, this Monday, but the other one, okay? That day is when you would tell me your project proposal. What do I mean? This will be, I'll come back to a slide to explain this one. This is the place where you choose a project, basically, from the list I have, or you tell me yours. And I will come back to what I mean when you tell me yours, especially. When you tell me my ideas, I'll be okay, I know what you're doing. But when it is yours, I need to know more. And so that is, I will call that project proposal. So there's something to submit, and that will happen on October 12th. Then I would say you're okay, you're not okay, you have to improve it this way, you have to tweak it that way, and things like that. And then let's say by mid-October or so, you're settled on a project and you'll start working on it. I don't want to wait until everything is finished and you've got a product to give me at the end, or a report to submit at the end. Instead, I would like to have a progress report in between. And so there will be a chance for you to submit, or a requirement. One of the milestones will be to submit a progress report. And this will be kind of where you are and how things are going and what adjustments you need to make and things like that. The final product for this will be a final report. This will happen on December 14th, and it will be a report. And I'm going to talk about this one. And the document that I have posted will tell you, this is a rough indicator of a size. Depending on what you're doing, it could be longer. And I would allow for something like that. This is written things that you would submit on Blackboard, right? But when the project is finished, it's not just the report, but the last week of classes, week 16, will be a time when we'll have project presentations in class. In the past, when things were in person, I used to, and I have large classes like this one, was not unusual to have all the time. So what we used to have, well, what I had a couple years, a couple times it was offered, was for students to create a 3-minute video presentation of their project. And so would watch it in class all together in a big screen. And that was a lot of fun. And you have something that you would have for yourself and use it for your job interviews and things like that. I don't think it makes sense now because we are doing things online. So what I would instead have is, would have these classes, and then people would present 3 minutes each of their things, because we have it recorded, so we have a recording. I will be open if you have a liking for the 3-minute video and you want to prepare it, and we'll still be watching, that will be okay. Then we'll have pieces of videos, but that is not the way I'm thinking about it. The most important thing is there is a week in which everybody is going to present their projects in class. It's going to be very short. And there is an art to it. There is the style to it. And I'll give you guidance when we get there to condense what you have done in 3 minutes. The report is separate. This is a presentation in class. Everybody will learn about what you did. Slides would be posted for the one that would accompany what you did. And so the class discussion will be organized in a certain way so that we get times for Q&A. So I said 3+2 is more like how each project will be, but it doesn't mean everybody would get the Q&A right after their presentations. We may want to wait and do it at the very end. That's more of the organization of it. But these are the milestones where things are, when your project proposal is due, when progress report is due, and when the final report is due. Project proposal. Let me check my time. We're doing fine. This is a time when it's okay for you to sip coffee. Go ahead for those who are watching or following along. The project proposal, I don't want it to be long. If you need to tell me more, there is background you have to provide and things like that, I would be okay, but I would want it to be 2-page document maximum. If you are going to propose your own project, then these things need to be there. And they don't have to be bullet points like this, but you could organize them, write them in paragraphs. But these are the points that it should hit home. And some people prefer them to have like this, and then under each one of these, you would, give me kind of your take on each one of them. That's also fine. The project proposal is not a report I would consider for how it is written, how it's organized, how it flows. And that's not the point. The point is for me to know enough to say, this is a good project, go ahead. No, you need to tweak it this way. So what do you need to accomplish with the project proposal? Describe what you intend to do. Describes the method you plan to use or develop. This may not be clear in your head right now, but you may give it a shot. Describe the data you will use and discuss how you plan to obtain it. If it is not something that's obvious, you have access to it, or you have chosen from the data set that I have pointed you. If it is not like that, you will discuss how to get it. That's an issue, by the way, to secure the data that you need for your work. Discuss relevant background work. If this is motivated by your research, whatever it is that where you are at, or whatever background work you have done, or if it's not your own research, but you've got some other thing that it's built on, I need to have some background discussion around it. This could be a paragraph long. And I think if a good job you do on this one will justify that I would support the project in a way. And so do take the time to provide that background work. And then I would like to see your tentative plan. So it's not a whole lot of weeks we have. If we just roughly think about it, it probably by the time you write this one and up to the submission time will be maybe 6 weeks or so. And then you will say, this week I will do this, we'll do this, and things like that. Not too detailed, but some idea that I know you have thought about it and you've got a plan at least, okay? That's what the project proposal would accomplish. If you do not propose your own, but rather pick from one of my so wonderful ideas that I already have, then you will just need to tell me which one it is. But because some of them are described with a little bit of an opportunity for you to take a different directions or some angle, I want you to say, I am going to work on this project idea, but here is the angle I would take. That is what I would want it to be. So it doesn't have to be even 2 pages long, but it will be, you call out which one it is, and you tell me what angle you will take, and that will be your project proposal. Okay, I have a document, and I will tell you that it is dynamic. I would probably add maybe a few things later on or something like that. And there are places where more additional information could be provided. And so you can come back to it and revisit it. But it's going to be some numbers, right? And I don't want everybody to pick the same project, of course. And I don't want to also have a reason for having to struggle for which project I will assign to which team. And therefore, when you pick from my ideas, I want you to say, here's my first pick. And then you would say, if I can't get that one, here's my second pick. That would allow me a little bit of accommodating your interest, but also come up with a good way to assign people projects. So I need your second choice when it is mine. If it is yours, you will get your choice, if I approve it, of course. In either case, whether you pick from what I have or you tell me yours, I need to know who your teammate is. I told you it will be a team of 2 or 3. And so if you already have somebody you worked with before, or some friend, or whoever it is, now you have had a chance to know each other's, at least roughly. For example, who somebody's favorite musician is, and you see, oh, we share a common interest here. Go. You can team up with someone. I'm kidding, but at least I wish we had more interaction so you know more each other, but at least you know to the extent that is possible. This is not always possible. Some of you do not have a good idea and you are free in a way, and I will match you up. And so if you tell me you haven't found somebody, then I will try to match you up. This will be best done before the project proposal is sent, and we could use email or at one of the office hours or something like that to tell me if you need my help in finding a teammate for you. But I would rather have it come from you. And I think you have by now some idea for who you want to work with. Working with other people in collaboration is a skill. It is an important one, in fact, and you should not always be looking for someone that you really, really get along with. It's not. Actually, it's a good idea to also learn from a discipline that's different from yours, or personalities that are different from yours, just so you get that experience. Okay, that was the project proposal. Final report is important, very important, and I'm going to have another document that will help guide you write a good report. And so I'll provide a guideline for writing the final report later. But this is the outcome of a project. Every project will have a final report, and associated with it, some people would have actually a code or a data product like the recommender, but everybody will have some kind of code, whether it is experimentation or some Python or some R code. So you will have a chance, other than the report, to have an associated code or data product. And then we have the short presentation in class that I told you. So we've got these 3 pieces. The report is not going to have the code in it. It will be an appendix. So that 8 to 12 pages I mentioned in the beginning is just the report, not the accompanying appendix about codes and things like that. The nature and organization of the report will depend on what project you have undertaken, but here are things that will be common to everyone. And this, I'll call it a rubric. This rubric is actually a good guide already. So you don't really need to wait for my detailed guideline for writing what a report is. These are the pieces I would expect. Introduction, or motivation or problem definition, you may call it. This is the place where you tell me what you are trying to solve or what you're trying to achieve. And this is the place where you tell me why it matters. And this, actually, the thing that you see in parentheses, and you call it in the introduction and motivation, will be a good guide for those of you who would be doing academic things, to keep in mind what you need to put in an introduction in a place that you call motivation. These are, you can call them section headings, depending on what project you are going to work on. The section headings may be different, but this is a generic section heading that could actually work well, and you may keep that in mind. So that's one of the items, one of the rubrics. The other thing is model or algorithm or method. This is where you give me a detailed description of your work, what it was about. And the third one will be where you discuss results and findings. This is where you don't just show me a plot and then leave it alone. You actually interpret it. You discuss your results. You say what it implies, and you make some observations, and you draw conclusions. That type of section is what I call results and findings. I have put a section called related work, but for most of you, the thing that you would do would have some work that other people have done, or there is some literature that's around it. This is a place I want you to come back and spend a little bit of time relating it and discussing that. So this is what a final report would look like. A more detailed guideline will come later on. Okay, I'm done now describing the setup, describing what the milestones are and the pieces that would be needed in the final report. Here is a place where I'm going to introduce the project ideas I have. We have, it's 9:47 now, so let me use a few minutes to talk about these ideas generally, and then I will ask Chris to take over and point me to go to Blackboard so that you can see the details of these ones, because there is a document that talks about these ideas, and these things are described in more detail. Okay, so let me walk you through now about the ideas I have. Be ready to read that document and pick things that you are interested in. But what I will tell you now is not repeat what is written there, but try to give you the gist of it in a way, and so you would understand. What you see in the first three, let me begin by saying that, are things that happen in my lab. And these are things that Helen works on, and to some degree. And so there is a benefit that you would get here, because there will be something that you will be guided, and something that will be a contribution to an active research program that goes on. That will be probably one way to begin this discussion. So the first project, and they tend to be, all three of them tend to be around bioinformatics type of work. That's not a coincidence. That is because Helen's ideas, or Helen's thesis work, her PhD, is in bioinformatics, and she's done some good work so far that would build a good foundation for some of these project ideas that can, not all of them, I'll talk about when they are different. So that's another context you need to understand. DNA, biologists would know it, is DNA. Everybody knows it. Within there is something that is interesting, and there is a part within a long alphabet that repeats, and some of these things are short. And so finding about them and working with them is a big deal in bioinformatics, and it happens all the time. And so there are a couple of project ideas there that are motivated by work we did on building a tool, finding algorithms for doing this, and doing some exploratory work on them. And some of them have led to places where we could improvements in the existing methodologies we have, in the existing software packages. We have a couple of them, and these ideas are related to that. And one of them actually is also related to visualization, because one of the stories we had in one of these works was finding an interesting relationship between how things are distributed when this DNAs, the repeats around them, for a particular kind of interesting pathogen, in fact, where this DNA is drawn from and the sequences are analyzed. There was data we have, and you will have access to that data, where the distribution of this on a world map, when the sequences are seen, is an interesting visualization. And that visualization has something that our tool has that could be improved. And so one of the projects is a combination of things that have to do with sequences and something that has to do with visualization. And if somebody picks just the visualization aspect of it, they may not need to know a whole lot about the sequences. But there is another reason why this will be an interesting project. Those of you who are in biology would know it. Every time you hear the word sequence, think of alphabets, things that would be, long alphabets. And some of them are not all of the 26 alphabets we know in English. They don't show up. Some of them, there's a few of them. You don't have to know a whole lot of them detailed there. But characters and these sequences are not just about biology. There are places where other things may come. Databases has got, Twitter has got, or things like that, where you actually have sequences of things and you have a reason to worry about them or to compare them or to search for them or things like that. And so some of the work that's discussed here and one of the project ideas there actually would make you see if there is another place where some of the same algorithmic things could be used for purposes that are not about biological sequence, about biological string data. Enough point about number one. Great project ideas there. The second one is not something we have directly really worked on, but very interesting works. And this one would relate to something that I call unsupervised learning, where you don't have the classification or a regression problem to solve, but you want to cluster. This is a huge problem or a huge area. People would do clustering for all kinds of different purposes, but this particular project idea would want you to cluster proteins. And so there are some interesting projects, one project idea described there. The third one has to do with networks. This, I would recommend it for people who have some exposure to graph or networks. And there are 3 project ideas described. Some of them are related to project idea 1 or the class of problems under idea 1, where you want to worry about distances between sequences and you want to formalize this and you want to think of them as networks, and there are reasons for it, but there is also some opportunity for having to pick your distance measures in a good way, whether you normalize or not, and how the network, sequence similarity network is built, and that will bring you to another work Helen, my lab has done on having to come up with a new model for doing sequence similarity networks. Read about them and you'll find. The other 2 projects that you see there, 4 and 5, or it's not just one project idea, there could be multiple of them, are related to what Ofer did in his guest lecture. Ofer is the person on the Spokane campus who talked about the mapping or map visualizations on interactive maps and things like that. There are 2 projects described here. One of them has to do with knowing if there is a Google Maps, some geographical information is taken and people's activity is desired to be classified. Is somebody walking or running or they're jogging? And there are some data that you would have to classify them. It is described in a very generic fashion, but here is a classification, but a machine learning problem that could use activities. By activity, I mean people's physical mobility. The other one that is related with what he does is related with visualizing health data on a map. And I think you get a sense of this from his presentation also. Okay, that was 5. Then I have another selection of topics here, and I have a few minutes. I may not get a chance to go to the document very much, but that's okay. COVID, no surprise, is a big topic, and we have a project idea on it that is of interest, I think, to very many of you. We have a current activity, in fact, in my lab that tries to see how to visualize sequence mutations over time for things that are around COVID data. And that visualization is what this project will talk about. There is some novel thing here, read it, and if you are interested, you pick it. But I don't usually like to have just A as a part. If I don't have a B, why do I have an A? Actually, I meant to write another one that is more or less around the work like Stephanie did when she talked about the IHME work, for example, there. That is not about sequence, it's not about mutation, they're just looking at how things are spreading and metrics they would use. We could define a project like that, and that would probably be an interesting thing to do. So one of the ideas I have there is to write a paragraph that could be point you back to her presentation and point you to some places where she said, we have data here, we've got something to do here. I think for some of you, it actually would be a great thing to do something like that. You may find something that IHME is interested in. It may open up something for you. That was what I had in mind, but I didn't write it up. So that will be project idea 6. 7, this is a place for people who have some background. If you have background in deep learning, and especially on something called generative adversarial networks, then there are some 3 very, very, very cool ideas that my lab is working on. You can get some guidance and on them. I don't think it is a good idea for me to describe details here, but generative adversarial networks are one of the biggest discoveries, if you like, one of the biggest things that have happened in the last 2-3 years now. And it's a big topic because they would help you generate things that are synthetic, that would be a lot of things that could solve a lot of problems in some ways. So I would recommend this if you have some background. If you're curious, you can learn, but it's very difficult for me in the course of this course to get you to a point where you could do this without having a background. And that's why it came a little bit later. Data sonification, this is not my idea. This is Chris's idea. Chris is the one who always takes us to Blackboard and shows us things. Here he's taking this class, and he discussed this idea with me. I asked him for permission, and he is interested in having a teammate to work on this. Just like we have data visualization, where we're using our eyes to visualize data, how about we use our ears to hear data? That is what data sonification. I was fascinated when he told me, and he has got music background. And so I have thrown in a bunch of things in that project document where I just wrote what Chris told me or what he kind of discussed. And it's not organized in any fashion, but it is very fascinating. So if you ask me what the project is, I can't put my finger on it because you need to define it. So if you're interested in that, talk to Chris, and this is what I want to say. This is the reason why your warm-up question today was about music. So there is a connection with music here that you probably would enjoy. The last 2 are not project ideas, but places where you can go to get more ideas. Kaggle challenge is a very popular thing, a very, very popular thing. So you get monetary rewards also. And so I have shown some things that you can go there to find ideas for a Kaggle challenge if you want to participate. It's very competitive, but my expectation for a class like this would be not necessarily to be a winning team to participate there, but having something good that I would consider will be a good product for a class like this. I did not pick any, but I could look at the challenges that are current now and maybe suggest a couple, but I would maybe leave it open for now. But in the document, I have said I will maybe come with the suggestions from the existing Kaggle challenge. The last one is a website where there is a whole bunch of data sets that people have put together that are good sources for inspiration for project ideas. I think browsing through them, if you don't have any one of these things appealing to you or you don't have your own ideas to suggest, might be a good place to spend. Sometimes when you have too many choices, it's difficult. I know that. And if somebody gives me 50 things to choose from, one of the things I would struggle with is to get through those 50 and know which one is. And you could get kind of lost. So if you are that kind of person, maybe this could be a bit of a challenge itself because there are many, but you just browse through them and see if there is anything that would be of interest to you. That's the point of these ones. So I've categorized them under 10. Each one of them has got multiple things, and we have a class that has got some 76 or so students. If I roughly take 2 or 3 projects, we're talking about 30 projects or of that order. And so it will be, this will not probably be enough to cover everybody, but I'm going to allow 2 teams to work on the same project, different teams to work on the same project if they have sufficiently different ideas to pursue. And so I think we are fine, but this document is going to be something that would leave. I've got 2 minutes, and so I'm going to stop sharing now and ask Chris to take us to Blackboard, just so I point to you where they are. I think that's probably a good way to use. But while he does that, let me see if you have any questions for me. Okay. You can ask me on the chat session. So thanks for being there. So this is the place, and you now see something called project is added. We are in contents, if you go there. So the project setup description is, can you click on that just for a sec? This is a place where you see the slide version or the text version of what I told in terms of slides. This will be what the project is, what the deliverables are, and what the deadlines are, and things like that, okay? And I think that's all I want to tell you, so you can come back. The project ideas, if you go back, this is the place, the project ideas document, the second one, is where you have what I told you, these 10 things, but there are paragraphs around them. So the short sequences. So every place where there is enough of a background to tell, there is a story. This is a place where we have taken some time. Helen has written some of these portions carefully so that you get an idea for what they are about. So we'll, you can read through them. You can scroll down, I think, as we go. So this was around the sequences. Here is where the protein clustering ideas would come and the things that are associated. Networks, sequence similarity networks would come, the normalizing, and so on. The 3 project ideas under it. This is where offer would come, physical activity classification, and the high resolution visualization of data on a map. And then here is the COVID related thing. I did not put the other idea, it will come later. And then you have generative adversarial networks, some background and the 3 ideas. And then comes Chris's idea, and this is what I talked about, data sonifications. There are some of them that would take you to a Wikipedia article, some videos and so on. I think even if you don't choose it, if in my view, this will be a good thing to browse through and just get familiar with it. There is plenty of idea, and there will be a good chance for somebody for 2 teams to pick it. Here is a place where you have the Kaggle challenges pointer. You go there and see, and here are the 2 places where there is, data sets for project idea inspiration. Thanks, Chris, and you can stop sharing now. I'm done. I think this was as fast as I could go, and I think you have followed me along. This is an important one because now you would know how projects are set up. If there is anybody who's got a quick question, I will be happy to answer now. I know it's a minute over 10, but let me take a question or 2 if you have. Anybody else got any questions? Silence means no questions. I will understand that. Was this helpful? Can I get a thumbs up or something on the chat that says this was good? Yes, okay, thank you. I'm asking for a yes and I get a yes. That's kind of nice. Okay, that's cool. Have a great weekend. I'll see you on Monday, and we will be having an overview of machine learning on Monday. And good luck with assignment 4. And you will hear my chat analytics results later today, okay? I've got meetings right after this, a series of them, so if I get delayed on getting back to you on chat analytics, forgive me, but I will try my best to do the usual time I would do. All right, I'll stop here. See you on Monday.